In this video, we're going to learn how to use arrow notation. And arrow notation is used to show how each vertex of a figure maps to its image. And I'll show you what I mean by that. The problem states PQRS is a parallelogram. Use arrow notation to write a rule that describes the translation of PQRS to its image, PQRS. And you can see that there are primes there, so that's how I know it's its image. Okay, in other words, I want to write a rule that shows how this slides, or in this case, translates to this. And let's start with one point, and I'll show you how arrow notation works. And I'm going to use point P. And so point P, let's start with that, or vertex P. There's my P. And where am I? I am -1, -2, -3, 1, 2. So that location is -3, 2. And here comes the arrow notation. I want to know where, and I'm using an arrow to show I'm moving, henceforth the arrow, to P prime. And where is P prime? All right, let's figure it out. So P prime is 1, 2, 3, 1, 2, 3, 4. So that is located at 3, 4. And that's arrow notation. Arrow notation shows where you started, and it shows where you end up. This is where the point is on the image. Okay, so I need to write a rule using arrow notation. And that starts off looking like this. For the ordered pairs x, y, what do I do to the x and what do I do to the y to get to wherever I'm going? So let's see, for P I moved over 1, 2, 3, 4, 5, 6, and up 1, 2. And that should be the same for all of these points. So let's go from Q to Q prime. That should also be 6 to the right, 1, 2, 3, 4, 5, 6, and 1, 2. That's, of course, true. And for R, 1, 2, 3, 4, 5, 6, 1, 2. All right, in other words, what's happening here? Well, what's happening very simply is this. To every x, I am adding 6. And to every y, I am adding 2. And that's how I am getting from my xy coordinate to my image. I'm adding 6 to the x and 2 to the y, and that will get me here. And that's what arrow notation is, and that's how you use it.